Camp Century was starting to grow, and so was Muckluck. We used 3 Peter plows to cut all the different trenches we needed. By making a series of undercuts, the width of most of the lateral trenches was greater at the bottom than at the top. This cut down on the amount of roofing material required. Before long, the first roofs began to go into place. Constructed of overlapping steel arches, these roofs could be put up very quickly. By this time, we had a crew working in a snow quarry cutting large bricks of snow. In this way, we made maximum use of the materials available at the site. Somehow, Muckluck seemed to be everywhere, always making himself useful. When a roof of steel arches was in place, it was covered with snow. Because it had been milled, this snow would harden into an extremely durable surface. Inside each tunnel, at the end adjoining the main communication tunnel, passages were cut through. Not all the excavation could be done by machine. The shovel was still a very useful tool. Next, work began on foundations for the prefabricated buildings that would be placed within the tunnels. Leveling the floor was very important to provide a good bearing for the foundations and prevent any building from settling unevenly. This was cold work. The temperature within these tunnels sometimes went to 20 degrees below zero, and this was summer. Prefabricated sections were delivered by forklift. The non-conductive wood and the air insulation barrier below it protected both the building from the cold of the ice floor and the ice floor from the warmth of the building. Every prefab that went into Camp Century had been pre-erected, tested, and then shipped to us as a unit. Every clip, every doorknob, every light switch came in a single shipment. In this way, we knew there would be no delays caused by missing parts. This is a standard T5 Engineer Arctic building, designed for cold weather use. Composed of plywood insulation panels, these buildings would provide space for comfortable working and living under the ice. Since every unit had been checked out in advance, our crews could put up one of these buildings in less than a day. As soon as the shell was completed, crews began to wire the buildings for interim power provided by diesel generators. As each unit was finished, I marked it off on the chart on my office wall. As the major interior work within each tunnel was completed, the entranceway was blocked up with bricks of snow. It took about 2 days to build one of these walls. Once in place, these bricks would bond together into a solid wall, and only a small entranceway would be left. We then used a bulldozer to push loose snow into the doorway of the tunnel to complete the seal. Later, an escape hatch would be placed at the end of a small wooden form for an emergency exit. When it was completed, the entrance was weatherproof and serviceable. Throughout the long period of construction, within the primitive facilities of the work camp, the men solved the everyday problems of working and living as best they could. Meanwhile, work had begun on the 4 nuclear trenches. These were the widest and deepest trenches and did not use the undercutting principle. On this cut, we used 3 plows simultaneously, 2 plows throwing up snow from below, the third cutting a spoil trench up above to prevent loose snow from sliding back into the cut. To avoid melting caused by the sun, much of this work was done at night. These scenes were filmed at 2 a.m. The continuous sunlight caused us plenty of headaches. A black tarpaulin was used to protect the section of this 40-foot cut most vulnerable to the sun's rays. Below, foundations and structure for the reactor building were put in place. Until the trench was covered, there was always a threat that the 40-foot arches would collapse a shoulder already weakened by the 24-hour-a-day Arctic sunlight. The faster the roof went up, the better. The frame for the reactor building was made of steel beams. Despite the cold and the constant winds, my construction workers climbed like monkeys over the scaffolding and rode the beams into place. At this same time, within the tunnels already completed, we were installing piping for water and electricity. Heavy insulation material was wrapped around every pipe to protect against the extreme cold. A copper heating element inside the insulation kept water lines from freezing. Flexible sewage lines also had to be run through the camp. At this time, to keep on schedule, we were using 12 and sometimes 14-hour shifts. For like any modern city, Camp Century required a complex of interconnecting corridors carrying a maze of piping of all sizes and shapes. One of our proudest achievements was our solution of the water problem. A steam hose with a special drilling nozzle was used to melt a hole 3.5 feet in diameter, 120 feet down into the ice cap, until a pool of water formed which did not drain off. This pool provided 10,000 gallons of fresh water daily. Throughout the camp, an extensive electrical system was now installed. For electrical heating would not only be clean, but it would also reduce the threat of fire. And fire was the worst hazard under the ice. From the very beginning, we had to take precautions against fire, or a storm closing the ramps, or any other disaster which might block the regular entrances to the camp. 16 of these escape hatches were strategically located throughout the various tunnels. In their off-duty hours, the men did what they could to amuse themselves with the recreational opportunities at hand. Bronco busting was one favorite pastime. By this time, muckluck was almost full grown. Living in the work camp was pretty much a do-it-yourself operation. Everything took longer and time was always short. Since our crews were working around the clock, if a problem came up, it couldn't wait. We tried to resolve it immediately. By early July, most of the heavy construction work on the tunnels was completed. Throughout this operation, it was a steady stream of heavy swings moving back and forth across the ice, more than any other single factor that made it possible for us to complete Camp Century on schedule. 25,000 gallons of diesel fuel, 110 tons, an all-time record sled load. The continuous flow of tractor trains bringing in enormous cargoes were like the dependable tortoise, slow but steady. But they were our lifeline. To service our many vehicles, a maintenance shop was constructed closer to the surface, both as a repair shop and as a garage. For the sub-zero temperatures meant equipment had to be kept warm. Otherwise, engines wouldn't start, lubricating oil solidified, and electrical connections froze. It was at this time that the Marine Fiddler arrived at Thule with the nuclear power plant. Designed for air transportability but transported by sea to reduce costs, the nuclear plant was the last major phase of our operation and the most difficult. This unit, for example, part of a vapor container, weighed more than 21 tons. Awkward to handle and with high centers of gravity, these packages were delivered to the ice cap over a road built specifically for their transport. More than 400 tons of piping and machinery arrived in this one shipment.